Asymptote. An asymptote is a straight line that a graph approaches without touching. There is two types of asymptote. The first one is vertical asymptote and another one is horizontal asymptote. In order to find vertical asymptote, step 1, we will let the denominator equals to 0 and solve for x. Then, we will analyze the asymptote by approaching the value of x from left and right hand sides. And for horizontal asymptote, we will find the limit of fx when x approach positive and negative infinity. Then divide the numerator and denominator with the highest degree of x in denominator. Oh here, in this function, we have 6 steps that you need to follow. So for the question, they give us fx equals to 4x minus 1 over x minus 2. For the first step, we need to find x-intercept. So how we want to find x-intercept? We have to y equal to 0, then you will get the answer. For y-intercept, we need to add 0 in the value of x, and then you will get y equals to 1 over 2. Next, find the vertical and horizontal asymptote. So for vertical asymptote, we will let the denominator x minus 2 equal to 0. Then we will get the answer x equals to 2. So this is our vertical asymptote. Next, we will try to find the analysis. So limit, let's say when x approach 2 from left hand side. For the function of fx is equal to limit when x approach 2 from left hand side. The function is 4x minus 1 over x minus 2. If we try to substitute, let's say we have the interval, here is 2. Let's say we try to substitute a value that very close to 2. For example, 1.999. So this is quite close for value of 2 from left hand side. So here, let's say we substitute the x into the 1.999. We will get negative 6,996. We can assume that this is negative infinity. Same as the second, let's say limit when x approach 2 from right hand side for the function of 4x minus 1 over x minus 2. Here, the interval is 2, and the value approached from right hand side that very close to 2, as example 2.001. After we try to substitute, then we will get 7004. We can assume that this is positive infinity. So this is vertical asymptote and the analysis. One is approach negative infinity, another one is approach positive infinity. Next, we look at horizontal asymptote. For horizontal asymptote, we will find the limit for fx when x approach positive and negative infinity. So, where our limit and function of fx is 4x minus 1 over x minus 2. So, from here, we will divide by the highest degree in denominator. In this case, we will divide all the numerator and denominator with the highest degree of x in denominator. Next, we will try to simplify. Then, we will get horizontal asymptote y is equal to 4.
For this question, we have to find f prime x and f double prime x. So first we are going to find f prime x. To find f prime x, we have to use fx, which is 4x minus 1 over x minus 2. And then we have to find u, u prime, v, and v prime. So we will use quotient rule to find f prime x, which is vu prime minus uv prime over v to the power of 2. So our f prime x will be negative 7 over x minus 2 to the power of 2. Next, we will have to find the f double prime x. To find f double prime x, we have to use our f prime x, which is negative 7 over x minus 2 to the power of 2. Then we have to find the u, u prime, v, and v prime. And then we will use the quotient rule to find f double prime x, which is vu prime minus uv prime over v to the power of 2. So our f double prime x will be 14 over x minus 2 to the power of 3. Next, we have to find the intervals where fx is concave up and concave down. To find if fx is concave up and concave down, we have to use the f double prime x. So from the previous question, we already get our f double prime x, which is 14 over x minus 2 to the power of 3. And then we have to find the important points. To find the important point, we take x minus 2 to be equal with 0. So x will be equals to 2. So x equals to 2 is our important point. Then we have to do the sign analysis for f double prime x. So from the important point, we already get two equations, which is x less than 2 and x more than 2. For x less than 2, for example 1, and we plug it into x minus 2, we will get negative. And for x more than 2, which is 3, and we plug it into x minus 2, we will get positive. So for f double prime x will be the same as x minus 2. For the concavity, it is based from f double prime x. So if it's negative, it will concave down, and if it's positive, it will concave up. So our concave up is 2 and infinity, and for concave down will be negative infinity and 2.
Assalamualaikum, my name is Nura Batusha binti Nurahim, and I'm going to find the extremum points and inflection points if there are any. Extreme points mean any points at which the value of a function is at the largest or smallest. They are both absolute and relative local minima and maxima. In fact, when f has a local extremum and at point x equals to c, the derivative f prime c must satisfy one of the conditions. F prime c equals to 0, f prime c is undefined. Such values of c is known as a critical point and is important in finding the extreme values for function. Since our f prime x is negative 7 over x minus 2 to the power of 2, when x is substituted by 2, our f prime x is undefined. The value of derivative f prime 2 does not exist. Hence, there is no extremum points. Since there is no extremum points, therefore there will be no inflection points also. Moving on to the last question, sketch the graph fx with the above information. Since our vertical asymptote x equals to 2, our horizontal asymptote y equals to 4, and there are no extremum point and no inflection point, this is how the graph should look like. The two curves shall not intersect with one another. As you can see here, when x is approaching 2 from the left hand side, the curve will move towards negative infinity, while when x is approaching to 2 from the right hand side, the curve is moving towards positive infinity. In conclusion, we can say that our question has a vertical asymptote x equals to 2, horizontal asymptote y equals to 4, no extremum point and no inflection point.